We are looking at D.14 in the Algebra 2 section in IXL. We are going to be talking about how to identify transformations and how to write the equation. So if I look at this, it says find g of x, where g of x is the translation 2 units up of the parent function of f of x equals the absolute value of x. So in my other video, we talk about the formula or the form of an absolute value function. So if I take my parent function, we have several different types of translations. H represents the horizontal shift, which means we are going left or right. The K represents the vertical shift, going up or down from the parent function or the origin. The A, the factor, talks about two different types of things. One is if it's a stretch or compress. And that would be considered, both of them are considered a dilation. And then the other would be a reflection across the x-axis if it is negative. So those are all the different types of translations or transformations of a parent function. So if I look at this example is telling us that we are shifting 2 units up. So remember, if we look at this, that means we are talking about going up and down. So that's a vertical change. So we're focused on adding a number to the back of this function. So we can say g of x is equal to the absolute value of x because we're not going left or right. And it wants us to go up 2, so we're going to add a positive 2 to the back. And that is all you need to do. Now looking at the second example, we see that it says it wants us to translate this function 8 units to the right. So we're going to use the formula that I just talked about. And it says we are going to go, we're not changing our factor at all, nor going up or down. So we're not going to use add or subtract a number in the back, but we are going to include a number that's inside. So I'm going to do the absolute value of x minus. Now that minus sign is part of the formula, and it wants us to go right 8 units. You have to remember that going right is a positive direction. So we're going to add a positive number in. So h is going to equal positive 8. So I'm going to substitute in a positive 8 for h, which means that minus sign stays there. So it's going to be the absolute value of x minus positive 8, and then that's going to be our answer. We next have example levels 3 and 4. Looking at this, we see for level 3 type of question, it says we have a reflection across the x-axis. So we talked about the part of our function that it's affected by the reflection is our factor. So that means a has to be negative. Now it didn't say that it had any stretch or compress, which means our factor is still going to be just a 1. So I'm not going to stretch it by making it bigger than 1, and I'm not going to make it condense or compress. So it's not going to be something that's between 0 and 1. But it is going to reflect across the x-axis, which means it's going to be going upside down. So my function is going to be g of x is equal to negative the absolute value of x. Now you could also say negative 1 absolute value of x, but 1 is the identity for multiplication, so I'm not going to actually write the 1. Looking at level 4, we see that there's multiple translations that it wants us to do. So it says find g of x, where g of x is a translation 5 units to the left. So that makes our h value inside the absolute value. Left means a negative, so it's negative 5. And in the back, our K, it says it's going to be 10 units up. So K is going to be going up, which is a positive direction, so it's 10. So what we're going to do, it doesn't talk about stretching, compressing, or reflecting, so A is not going to change. It's just going to be 1. But inside the absolute value, I'm going to write it over here for right now, we have x minus. And then we have a plus sign in the back for the formula. So our h value is a -5. So I'm going to plug in -5 for h. And we notice something happens here. We have x minus -5. And we need to remember that when we multiply negative times a negative, it changes to a positive. So my two double negatives, my two minus signs are going to change to a plus sign. So inside for my answer, we actually have the absolute value of x plus 5. And then on the outside, we're going 10 units up. So we're going to add 10 to the back of this function outside of the absolute value. And that means I'm going to be shifting on my graph left 5 units and up 10 units. The next is level 5, where we're going to be given a graph and we're going to be asked to write the function. So what I always like to do is I like to draw a point where the vertex is. And if I notice my vertex is going to be a point, h comma k, because our formula, if you look at this, is a times the quantity of x, the absolute value of x minus h, and then plus k outside. So my h value didn't move from the origin, so it is 0. My k value did move. It shifted up, so h is positive, and it went up 7 units. All right. And then my slope, my factor, it went up 1 unit, right 1 unit. So A is just positive 1. It's not upside down, so it's not negative. So I don't need to change anything for that. So for my answer, it's going to be g of x equals. A is just 1, so I don't need to write anything. X, we had 0, so I don't need to put x minus 0, but I can if I want. And then it went up 7 units, so I'm going to add 7 in the back. And that is how you do the level 5 types of problems. Looking at level 6, we see another graph. We're going to do the same concept. We're going to write our function. So I look at this, my vertex. It went right 1 unit for h, so it went a positive 1 unit. But it didn't go up or down. So my k value is just 0. My slope, we notice we are going down. So A is actually going to be negative. Don't know. And then we're going to be going right 1. So if we look at this, we went down 1 and then right 1. So our A is just going to be -1. So when I write this equation, we have g of x equals, that's a -1. You can put a 1 if you want. And then you have the absolute value of x minus. And we went right 1 unit, so I'm going to put a positive 1 inside my formula. Remember that minus sign is part of the formula. And then we didn't go up or down, so I don't need to add anything to the back. And that is how you do that example. If we look at the final level, level 7, we have multiple different transformations happening here. So if we look at our parent function, we notice our vertex is going down 5 units. Now I look at it, it didn't go right or left. So my vertex is at 0, -5. So if I want to write my function of g of x, we see that it did reflect, so that makes my slope negative. Now, if I go check my actual rate of my rate, what I'm going to do is try to find a point that intersects with this graph, and we see one all the way down here. So I want to count how many boxes it goes down. It goes down 1, 2, 3, 4, 5. So it went down 5. And we're going to go 1, 2, 3, 4, 5, 6, 7 to the right. So my reflection is negative, and it's going to be 5 over 7 with the absolute value of x. It didn't go, our vertex did not move left or right, so there's nothing else inside. But it did go down, so it's going to be minus 5. And that's how you do the harder level 7 problem.